Hello students, I hope all of you are doing good. Let's start today's chapter, decimals. In this chapter, we're going to discuss about all these topics. Okay, so let's get started. Introduction. In our earlier chapters, we have learned about decimals. Decimal numbers are fractional numbers with the denominator 10, 100, 1000, etc. For example, 2 by 100 is equals to 0.02 and 5 by 10 is equals to 0.5. And 3 by 1000 is equals to 0.003. Okay. The dot, this is called the decimal point and read as simply point. This 5.2 is read as 5.2 or 5 decimal 2. Here the numbers before decimals on left hand side are called whole number part, and numbers after decimals on right hand side are called decimal part. For example, 5.2. Before point or to the left side of point, this is the whole part and this is the decimal part, right? Concept of 1/10. To understand the meaning of 1/10, let us see the following examples. 1 out of 10 parts of the rectangle is shaded, or 1/10 of the rectangle is shaded. We write it as 1 by 10 or 0.1. Here 0.1 is the decimal form of fraction 1 by 10. 2 out of 10 parts of the circle is shaded, or 2/10 of the circle is shaded. We write it as 2 by 10 or 0.2. Here 0.2 is the decimal form of 2 by 10, right? Let's do exercise 8.1. Number 1. Express the shaded part of the following shapes both as fractions and as decimals. Okay. Let's do the first part. See how many shaded parts are there. There are 1, 2, 3, 4 shaded parts. Okay. Out. And how many total parts are there? 10 parts. So this is the fraction. Now we have to write it as decimals also. So how are you going to write it? You will write it as 0.4. Okay. Decimal greater than 1. Look at the following figures. Here one whole square is shaded and also 1/4 tenth of another square is shaded. Thus total shaded part is 1 plus 4 by 10 or 1 plus 0.4 is equals to 1.4. Okay. Remember, one whole square shaded is equals to 10 by 10 read as 10/10 or 1.0. Okay. Example, draw circles and shade 22 tenths in it. Okay. So here 22 tenths means 10/10 plus 10/10 plus 2/10. 10/10 is equals to 1 whole. So this is 1 whole, then 1 whole, and then we have shaded here 2 parts out of 10, right? Concept of 100. Look at the figures given below. In the first square, 2 out of 100 parts are shaded. That is 200 of this square has been shaded. We write 2 by 100 or 0.02. Here in second graph, 26 out of 100 parts have been shaded. It means a 2600th of this square is shaded. Okay. We write it as 26 by 100 or 0.26. Representation of decimals on number line. We have learned the representation of whole numbers and fractions on a number line. Now we will learn to represent decimal numbers on the number line. Suppose we have to represent 1 by 4 on the number line. 1 by 4 means 1 whole and 4/10. Thus, see, this is 1 whole and then this is 4 by 10, that is 0.4. Okay. The procedure to represent decimal numbers on the number line is that first we draw a number line and mark the whole numbers, that is 0, 1, 2, 3, 4 on it, and then divide the portion between 1 and 2 in 10 equal parts, and fourth part will be the 4/10 or 0.4. We mark this point as A. So thus A represents 1 by 4 on the number line. Place value. Let us try to write the place values of the digits in the decimal numbers, that is 184.45. Here the digit 1 is at, see, this is the digit. Here 1 is at 100th place, so its place value is 100, and 8 is at 10th place, so its place value is 80. 4 is at 1st place, so its place value is 1. Okay. Now the digit 4, this one is at 10th place, so its place value is 4 by 10. and this 5 is at 100th place, so its place value is what? 5 by 100. Okay, thus this number can be written in the expanded form as under, which is given here, right? Pictorial presentation of decimal number. There are two ways. Example for 184.45, see 100 block and 8 10 blocks, 4 1 blocks, 4 10th blocks and 100th blocks, 500 blocks. Okay, so the number is 184.45. Okay, no more. Difference of place value and face value. In the adjacent example, this one, place value of 1 is 1 into 100 is equals to 100, but face value is only 1. Place value of 5 is 5 by 100, but face value of 5 is 5, right? Decimals in the place value chart. Let us write the following numbers in their expanded form using the above place value chart. Okay, so you have this number 0.87. Okay, 0.87. 8 is at 10th place, so we will place 8 here. 7 is at 100th place, so we will place 7 here. Next number is 3.48. 3 is at 1's place, so we will place 3 at 1's place. Then 4 is at 10th place and 8 is at 100th place. Okay, similarly, these two examples also, you will place all the digits like this only. Example 2, write the following numbers in expanded form. 47.79. So, how are you going to write it? You will write it 40 plus 7 plus 7 by 10 plus 9 by 100. Okay, no more. Have you noticed that as we shift from left to right by one place, the multiplying factor will be 1 by 10 of the previous one. Okay. Example 3, write the following decimals. 4800 means 48 by 100 or 0.48, right? Exercise 8.2. Number 1, write the following decimals in place value chart. Okay, so you will write here 100th, 10th, 100th. Okay, don't forget to write th. Then you have your decimal point, then ones, tens, hundreds. Okay, you have 0.78, 0.78. Then you have 45.16, 0.16. Okay. Next, comparison of decimals. A. To compare two or more decimal numbers, we first compare the whole number part. In any decimal number, if whole number part is greater than that number is bigger. B. If the whole number part of the decimal numbers are equal, then we start comparing the extreme left digit of the decimal parts. If they are equal, we compare next digit and so on. Let us try to understand this with the help of following examples. Example 5. Which is greater? 75.18 or 175.89. Clearly, we can see that there are three numbers or three digits in whole part in this number. So, this decimal is greater than this one, right? Similarly, you will compare 15.28 and 15.98 and example 7 also. You will do in this way only. Okay. Next, equivalent decimals. Let us compare the following decimals. 200 by 1000, 20 by 100, 2 by 10. If we simplify them, we get, so what will you get? 200 by 1000 is 2 by 10. Okay. Now 20 by 100. 0 goes. 20 by 100 is 2 by 10. Okay. So 2 by 10 is what? 0.2. This is also 0.2. So 0.2 is equals to 0.2. Okay. Right. Similarly, this part is 0.50 is equals to 0.5. 0.50 is equals to 0.5. 0.900 is equals to 0.9 and 0.600 is equals to 0.6. Thus, 2.3, 2.30 and 2.300 are all equivalent decimal numbers. Okay, no more. This implies that by adding any number of zeros after the extreme right digit in the decimal part, the value of the decimal part does not change, it remains the same. Okay. In example 8, you will arrange all the decimal numbers in ascending order, right? Let's do exercise 8.3. Fill in the blanks by using the given signs. Okay, you have 25.12 and 14.89. So first we will compare the whole number parts. So here we have 25, here we have 14. So clearly this one is greater than the other decimal. Okay. Conversion of decimals. There are two cases. A. Conversion of decimals into fractions. B. Conversion of fractions into decimals. Conversion of decimals into fractions. We have learned till now to write the fractions having denominators 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how do we write a decimal number like 2.4 as a fraction? We follow the following steps. Step 1. Write the given number without the decimal point as the numerator of the fraction. Step 2. Write the denominator of the fraction by inserting as many zeros on the right of 1 as the number of decimal places in the given decimal's number. Step 3. Simplify the fraction to get the lowest form. Here 2.4 is equals to 24 by 10, or we will convert it into simplest form. We'll get 12 by 5, right? Example 10. Convert the following decimals into fraction in the simplest form. 0.3. Okay, so there is only one digit after decimal, so in denominator we'll write 10. 0.34. okay, how many decimal places are there after decimal, or how many digits are there after decimal? There are 2 digits, so in denominator we will write 100 and numerator is 34, right? Next, conversion of fractions into decimals. Okay, but first learn some common mistakes. What are the common mistakes? Don't forget to change the answer into A, simplest form, and B, finally into mixed fraction form, but if required only. Okay, now let's learn how to convert fractions into decimals. We have already read that how a fraction with denominators 10, 100, 1000, etc. can be expressed in decimals. Now we will learn that how a fraction having denominator other than 10 can be expressed in decimals. The method for it as follows. Number 1. Divide the numerator by the denominator till a non-zero remainder is obtained. 2. Put a decimal point in the dividend as well as in the quotient. 3. Put a 0 on the right of the decimal point in the dividend as well as on the right of the remainder. 4. Divide again just as we do in whole number. 5. Repeat step 4 till you obtain remainder 0 if possible. Example 11. Convert the following fraction into decimals. Okay, so you have 27 by 4. Let's divide 27 by 4. 4 6 are 24. Okay, 3 remainder. Here what will you do? You will put a point here and then you will add a 0 here. 4 7s are 28. Remainder is 2. Now you can add 0. 4 5s are 20. Okay, now the remainder is 0. So this is the required decimal. Means when this fraction means 6.75. Okay. No more. While dividing, if in denominator number 2 or 5 or both are present, either ones or multiples number of times, then only we will get a 0 as a remainder. Type 1. B. If number is 3, 7 by 50, then factors of denominators are 2 into 5 into 5. Since only factors of 2 and 5 are there in denominator, when 7 is divided by 50, finally remainder will be 0. Type 2. C. If number is 7, 11 by 30, then factors of denominators are 3 into 2 into 5. Here 3 is other than 2 and 5, so we will never ever get 0 remainder when 11 is divided by 30. Okay. D. My inspection tell which out of 6 number will be of type 1 fractions. Okay, so you can inspect and find out which are type, which or out of these fractions which is of type 1, right? Next, applications of a decimal. But before proceeding, let's remember, write whether it is correct or not. If it is not correct, the correct answer, and if not correct, write the correct answer. 70 paise is equals to 0.70. It is correct, right? 80 paise is equals to 0.8. It is wrong. Correct answer is rupees 0.80. And 390 paise is equals to 0.900. It is wrong. Correct answer is rupees 0.90. Okay. Remember, similarly, 12 rupees 70 paise is written as rupees 12 decimal 70 and not as 12.7 rupees. Okay. And now you have to write all these currency in decimal form. Okay. Now, applications of decimals, where we apply this decimal form in money values. We know that 100 paise is equals to rupee 1, right? It means 1 paise is equals to 100th of a rupee. 1 paisa is equals to 1 by 100 rupee, that is 0.01 rupee. 1 paisa is equals to 0.01, 5 paisa is equals to 0.05. 10 paise is equals to 0.10 and 50 paise is equals to 0.50. Also 5 rupees 50 paise is what? 5 rupees 5 plus 50 paise means rupees 0.50. So you will get rupees 5.50, that is 5 rupees and 50 paise. Okay. Similarly, 75 rupees and 75 is this. Okay. Use of decimal notations in measure of lengths. We know that 10 millimeter is equals to 1 centimeter. 100 centimeter is equals to 1 meter. 1000 millimeter is equals to 1 meter. So 1 millimeter is 1/10 of a centimeter and 1 centimeter is 1/100th of a meter. 1 millimeter is equals to 1 by 10 centimeter, that is 0.1 centimeter. 1 centimeter is equals to 1 by 100 meter is equals to 0.01 meter. Okay, and 1 millimeter is equals to 1 by 1000 meter is equals to 0.01 meter. Okay, thus using decimals we write 5 centimeter is equals to 0.05 meter. 15 millimeter is equals to 1.5 centimeter is equals to 0.015 meter. Okay, 50 centimeter and 6 millimeter is equals to 50.6 centimeter. 25 centimeter is equals to 0.25 meter. 4 meter 30 centimeter is equals to 4.30 meter, and 21 meter 57 centimeter is equals to 21.57 meter. Okay. Also 15.25 meter is 15 meters and 25 centimeters. 4.51 meter is 4 meters and 51 centimeters. Okay. We know that 1000 kilometer is equals to 1 kilometer. So 1 meter is 1000th part of a kilometer. 1 meter is equals to 1 by 1000 kilometer is equals to 0.01 kilometer. 5 meter is equals to 0.005 kilometer. 60 meter is equals to 0.0660 kilometer, and 59 meter is equals to 0.059 kilometer. Using decimals we write 8 kilometer 501 meter as 8 kilometer plus 0.501 kilometer, that is 8.501 kilometer. 12 kilometers 65 meter as 12 kilometers plus 0.06 kilometer, that is equals to 12.06 kilometer. Okay, no more. It is important to know that we always use 2 digits to represent paise while writing in decimal form. Thus, though 0.50 and 0.5 represent equivalent decimals, but 50 paise is written as 0.50 rupee and not 0.5, right? Remember that. Number 2, same is applicable for centimeter to meter also. Number 2, when meter or gram changes to kilometer or kilogram, there should be 3 place of decimal. Example, 3 kilometer 500 meter is equals to 3.500 kilometer, and 5 kilogram 75 gram is equals to 5.075 kilogram, right? Next, use of decimals in measuring weights. We know 1000 gram is equals to 1 kilogram. So 1 gram is 1000th of a kilogram. 1 gram is equals to 1 by 1000 kilogram, that is 0.001 kilogram. 1 gram is equals to 0.01 kilogram. 5 gram is equals to 0.005 kilogram. 50 gram is equals to 0.050 kilogram. 500 gram is equals to 0.500 kilogram. Thus, using decimals, we write 15 kilogram 607 gram is equals to 15 kilogram plus 607 gram, that is 15 kilogram plus 0.607 kilogram, and after adding we will get 15.607 kilogram. Okay. Similarly, we will do this. Now, let's do example for 12. Express the following in as rupees using decimals. 95 paise. How are you going to write it in decimal? Rupees 0.95, right? Example 13, express as meters using decimal. You have this number 75 centimeter. You have to convert into meter. So what will you do? You will divide it by 100. So you will get 0.75 meter, right? Let's do exercise 8.4. Express the following as rupees using decimal. 79 paise, and you have to express in as rupees using decimal. How are you going to write in decimal? Rupees 0.79, right? Next, addition and subtraction of decimal numbers. Decimal numbers are added and subtracted in the same way as whole numbers. We have to take care that the decimal point comes directly underneath one another. For example, you have to add these two decimals. So what will you do? We will arrange them in columns, and remember, decimal should be underneath the decimal, okay? And in subtraction also, we will apply the same procedure. That is, we will arrange in columns and then we'll subtract as we subtract whole numbers, right? In some cases, the decimal places are not equal in the numbers to be added or subtracted. For example, 16 point, if we are adding 61.4 and 78.56, we put a 0 in the vacant place. That is, we convert the given decimal numbers in equivalent decimals as enter, and then we will add, right? No more. For unlike decimal numbers, we put a 0 at vacant places in place value chart, like given here, okay? So decimals are used in day-to-day situations of our life. We shall try to understand these by some examples. Example 16. Reena bought ice cream costing rupees 75 and 80 paise, pens costing 15 rupees and 25 paise, and a purse costing 205 and 50 paise. How much money did she spend it on? So you have to find out the total money spent. So what will you do? You will add all the three amounts. So 75.80, then 15.25, and 205 rupees and 50 paise. Now add them up as we add whole numbers. 5, 8 plus 2, 10 plus 5, 15, decimal, you 1 carry, 5 plus 5, 10 plus 5, 15 plus 1, 16, 1 carry, 7 plus 8 plus 1, 9, 296 rupees and 55 paise, right? Let's do exercise 8.5. Add the following: 1.15, 3.78. Let's add. 8 plus 5, 13, 1 carry, 7 plus 8 plus 1, 9. Then decimal, don't forget to put decimal, okay? 3 plus 1 is 4. So this is the answer, right, student? Now you will do the practice of the remaining questions.